Hey everybody, Mr. Judson here. Here's our video lesson for April 14th, Tuesday. I will do Tuesday and Thursday again this week, and it looks like next week I'll start going to 3 days a week, which will probably be Monday, Wednesday, Friday. Alright, so let's start with an entry task here. We've got the summation for I equals 4 to 7 of 2i squared plus I. You guys see if you can find that answer. Alright, so we want to start with 4 and plug that in first. So if I do that, I'm going to get 4 squared. That's 16 times 2, that's 32, plus 4. There's for my first I value that I'm plugging in. And then I want to plug in a 5. So 25 squared times 2, that would be 50, plus 5. Then I'll plug in a 6. So that'd be 36 times 2, that's 72 plus 6. And then I'll plug in a 7, that'll be our last number. And so I get 49 times 2, that would be 98 plus 7. And so when I equals 4, I get 36. When I equals 5, I get 55. When I equals 6, I get 78. And when I equals 7, I get 105. And so now we just need to add those up. So 36 plus 55 plus 78 plus 105. And I get a total of 274. So our goal for today is, what if this was the summation for I equals, let's just say 1 to 72. I don't want to plug a number in 72 times. That would just take too long to answer that question. And so what we want to do is we want to find a quicker way to do that. Which again, we've got this elementary school kid to thank for that. I think these formulas he developed somewhat later as he got older. 6th grade maybe, no, I don't know. But as he got older, he developed these formulas. And so, we're going to go ahead and take a look at those. So, the first thing we want to do is we want to say that we're developing some rules for summations. So, if I have the summation for I equals 1 to n of f of x plus g of x, one of the things that you can do, now this f of x would be like the problem we just did where we had 2i squared, and my g of x would be plus I. So it really just means two terms. And what we can do is we can separate that into two different summations. So I would say this equals the summation for I equals 1 to n of f of x plus the summation for I equals 1 to n of g of x. And so what I can do is I can separate into two different summations and do each one individually. That's going to be an important thing for what we do today. We're going to want to separate it into different terms. So that's rule number 1. Rule number 2 is if I have the summation for I equals 1 to n of c times f of x. So c is just a constant. It's like in our entry task we had 2i squared. 2 is the c value. Okay? We can bring that c value to the outside of our summation. Summation for I equals 1 to n of f of x. And whatever this answer is, we'll just multiply it by c at the end. Rather than multiply by c every single time, we'll do that at the very end. Alright, so here are some of the rules that this kid has helped us out with. So first of all, summation for I equals 1 to n of some constant. I think we had a homework problem like this where it was like summation for I equals 1 to 5 of 10. That means it's just a constant there. There's no I value to plug our numbers into. Well, if you do that, that's just going to be, in our homework problem, it was 10 plus 10 plus 10 plus 10, however many times we had that. Well, this is going to be C plus C plus C, whatever that constant is. And the number of times you'll have that is from 1 to n. So whatever n is, that's how many C's I'm going to write down. Well, if you're just adding the same number over and over again, that's how we started out learning multiplication. 4 plus 4 plus 4, that's 4 times 3. Well, if I have n C's written down and I'm adding them all together, that's just n times C. All right, our next formula, summation for I equals 1 to n of I. So if you think about that, I'm going to plug in a 1, then a 2, then a 3. So this is really 1 plus 2 plus 3 plus 4 plus 5. And that's kind of what that kid did. The elementary school kid, he said you take the first number, which is 1, plus the last number, which is n. We're going to call it n plus 1. And then the number of pairs you have is just n divided by 2. So there's our formula. If I was doing something like the summation for I equals 1 to 10 of I would do 10 over 2, that's 5, times 10 plus 1, that's 11. So 5 times 11, that would be 55. All right, next formula. Summation for I equals 1 to n of I squared. So if I plug in a 1, I'm going to do 1. Plug in a 2 and squared, I get 4. Plug in a 3, you get 9. So this is like 1 plus 4 plus 9 plus 16 plus 25. We're adding perfect squares. And we're just going to write these formulas down. It's hard to make sense out of all of them. I think this kid did a lot of work to get from here on. So this formula is n times n plus 1 times 2n plus 1 divided by 6. So, again, if I was doing the summation for I equals 1 to 10, I would have 10 times 11 times 21, multiply all that stuff together, and then divide by 6. All right, our next formula. So we're going to go up as far as I to the 5th power. There are formulas for things beyond that, but that's as far as we need to go. So if I had the summation for I equals 1 to n of I cubed, the formula for that is n squared times n plus 1 squared divided by 4. If I go for I to the 4th, the summation for I equals 1 to n of I to the 4th, and this is where they start to get a little messy. The answer for this is n times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1, and divide that whole thing by 30. I kind of feel like I can hear you guys laughing right now. Yeah, that's, how did that kid figure this out? That's a crazy formula. I have no idea where that comes from. That is way beyond anything that I can handle. All right, one last one. Number 8. Summation for I equals 1 to n of I to the 5th. And that's going to equal n squared times n plus 1 squared times 2n squared plus 2n minus 1 all over 12. And that's probably just as messy as the last one. So really, this is the thing that I needed to get to in this chapter. This is stuff that we need to know and understand next year for calculus, because we will be doing things with this. I think it starts second semester, but we're going to add up basically a lot of rectangles to find the area of shapes. And we need these formulas to help us add up all those rectangles. All right, so yeah, make sure you have all these copied down in your notes. You probably want to hit the pause button if you don't have them done yet. So yeah, these formulas are all in our book. You can find them on page 679. They're in a blue box. They write them a little bit different than the way I did. But one thing I really want to make sure that we get from this is every single summation starts at 1. So if I have the summation for I equals 5 to 72, these formulas don't work. Sort of. I would do the summation for I equals 1 to 72. I didn't really want the first 4, so then I would subtract the summation for I equals 1 to 4. That's the way you get around that. But for this, we have to start at 1 to use these formulas. All right, so here's an example of one where it doesn't start at 1. How would I do this? Well, and I don't really care what f of x is right now, but I know that the formulas only work when you start at 1. So what I would have to do is I would do the summation for I equals 1 to 60 of whatever this is. And I didn't really want the first 14 of these, right? I want to start at 15. So what I'd do is I'd go back and subtract the summation for I equals 1 to 14 of, again, whatever this function is. And so that's the way you get around it if it doesn't start at 1. We just say, let's go ahead and do it from 1 to 60, but I really didn't want the first 14 terms. So I'll subtract those. Okay, so let's do a sample problem together. So one of the first things I want to do is I want to break this down into separate terms. So I'm going to write this as the summation for I equals 1 to 30 of 3i minus the summation for I equals 1 to 30 of 4. And we saw that whenever there's a constant, we could bring that to the outside. So let me just erase that. I'll move that 3 to the outside. And so now I know that the summation for I is, let me just write it down here, it's n over 2 times n plus 1. And the n value is the number that's up here, 30. So what I have is the 3 that's on the outside times 30 over 2, that's 15, times 30 plus 1, and then minus, here I have a constant, and so our formula was whenever there's a constant, we're just going to do the n value times c. And so what I get is 30 times 4. So now this summation, if I use my calculator, I've got 3 times 15, that's 45, times 31. I get 1,395 minus 30 times 4, that's 120. So if I subtract that, I'm going to get 1275. There's my answer. Now, one of the questions you might ask is, Judson, why didn't you just use your calculator? The way I showed you guys last time. Well, I want to make sure I understand how to work through this. The calculator may not always be available. I would certainly use my calculator as a way to double check this. And last time I told you guys, use x instead of I, but you could use I if you want. right? I could go, let's see, math. I'm going to arrow up because you get to the bottom of the list faster that way. There's summation, option 0. All right, I'm going to do the summation for, I'm going to say alpha I equals 1 to 30. And inside here I have 3i, so I'll go 3 alpha I minus 4. And then I hit enter, and there it is, 1275, so the answer checks out. I just use X because I don't want to hit that alpha button every time, but you can use whatever that letter is. All right, you guys go ahead and try this one. All right, so, this time it's the summation for k equals 1 to 25. They didn't use I, but that's okay. The same formulas apply. We're just using the variable k instead of the variable I. All right, so I'm going to break this up into two different terms. So I've got the summation for k equals 1 to 25 of k squared minus, there's a constant here, so I'm going to write that on the outside, and then the summation for k equals 1 to 25 of k. And so now I just need to go to the formula where we used I squared. Even though this is k squared, it's the same formula. And so that formula was this right here. I had n times n plus 1 times 2n plus 1 over 6. So the n value is 25. So I've got 25. Here I've got 25 plus 1, so that's 26. Here I've got 2 times 25, which is 50, plus 1. That'll be 51, divided by 6. We'll figure out what that is in the calculator in a minute. Minus 2 times, and remember our formula for I was, in this case k, but the formula for I was n over 2 times n plus 1. See, the thing that I think is important about writing these formulas down is the more often you write them down, the easier they become to remember. And so I'd encourage you guys to do that. All right, so my n value is 25, so 25 divided by 2, that's 12.5. And then 25 plus 1, that's 26. And so now I grab the calculator. I've got 25 times 26 times 51 divided by 6. And that is 5,525 minus, here I've got 2 times 12.5, which would be 25 times 26. And I got 650. And so now we just need to subtract those. And I get 4,875. There's my answer. Now, if you forgot these formulas, you could always go back and plug in a 1, and then a 2, and then a 3, and then a 4, and so on, all the way up to 25, and you would get the same answer. But I think the odds of doing that, I don't care who you are, whether you're me or someone else, you're probably not going to get this answer. You will probably make a mistake somewhere along the way. So these formulas are really designed to make this a lot easier. All right, you guys go ahead and try this one. We've got the summation for n equals 1 to 75 of 2n squared plus 4n minus 12. I wish the book would kind of avoid this variable because our n value is really 75, and now we've got these other n's in there, and that makes it a little confusing. If you want to, you can just say this. You can just say n equals I, and then rewrite the problem, summation for I equals 1 to 75 of 2i squared plus 4i minus 12. And that might make it a little easier just because now it matches our formulas. You guys go ahead and give it a shot. Alright, so I need to divide this up into 3 different terms, or 3 different summations. So I've got 2 times the summation for I equals 1 to 75 of I squared, plus 4 times the summation for I equals 1 to 75 of I, minus the summation for I equals 1 to 75 of 12. Alright, so this formula would be, starting to get these memorized already, n times n plus 1 times 2n plus 1 over 6. This formula was n over 2 times n plus 1. And this formula was n times that constant. So I've got the 2 that's out in front times the n value, which is 75, times 75 plus 1, that'll be 76. 2 times 75, that's 150, plus 1. And then divide that whole thing by 6. Plus this constant out in front, which is 4. I've got n divided by 2. I'm going to write this as 75 over 2. And then times n plus 1. So that'll be 76. And then minus 75 times 12. The reason I wrote it this way is I could look at this and say, well, 4 and 2, those can both be divided by 2. This is now a 2. And that makes it a little bit easier to multiply that out. Alright, so for the first term here, I'm going to get 2 times 75 times 76 times 151 divided by 6. And so I got 286,900 plus, here I've got 2 times 75, which would be 150, times 76. That's going to be 11,400. And then minus 75 times 12, that would be 900. So now we just got to combine those numbers. And so I'm going to start with 286,900 plus 11,400 minus 900. And my final answer is 297,400. And so again, I can go and check this real quick on the calculator using the summation feature. And so I'll let you guys go ahead and do that. Alright, one last problem. We'll try and get one in with a larger exponent. You guys go ahead and try this one. Alright, so first thing I'll do is bring that 3 to the outside. So I've got 3 times the summation for I equals 1 to 80 of I to the 5th. And our formula for I to the 5th was n squared times n plus 1 squared times 2n squared plus 2n minus 1, all over 12. Alright, so I've got the 3 to start with, times n squared, so that's going to be times 80 squared, times n plus 1 squared, so that's 81 squared, times, let's see, this is going to be oh boy, 2 times 80 squared. I'll just write this down and I'll figure out what it is in a minute. Plus 2 times 80, that'd be 160, minus 1. And then we're going to divide this whole thing by 12. So what I'm going to do is, because 3 divides into 12, I'm going to get rid of this 3 and we'll make this a 4, and I'll just divide by 4 at the end. So with my calculator, I'm just going to type this in exactly the way it looks. In parentheses, I've got 80 raised to the second power. And then I got to arrow out of that exponent. And I'll do another set of parentheses. 81 raised to the second power. And then I've got my third set of parentheses. I've got 2 times 80 squared plus 160 minus 1. And then divided by 4. Ooh. Yeah, so this is a big answer. I got 1.360 times 10 to the 11th power. So that means I need to take this decimal point, because the exponent's positive, I would move this in the positive direction 11 places. So really the best answer I can get, here's everything my calculator has. 1.360383984. If I start here and I go 11 places, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know what numbers come after this, so I just got to add zeros. There's 10, 11. There's the answer to that problem. So we got here 136,038,398,400. And that part is rounded. I'm fine with this answer right here. I mean, that's a pretty big number. All right, I haven't posted any answers for you guys the last couple days, and that's because we did all odds. There weren't any even problems. So you have access to all the answers in the back. This is our 5th assignment since we've been out. It's on page 682. We'll do 41 to 50. So on Thursday, I'll have some answers for those even problems for you. Remember, you can check those on your calculator. So you don't really need my answers. But if you just want to see the work, I'll still have it there. All right, that's it. You guys take care. 2 comments. One, the number of views has gone way down. Hopefully you guys did not hear the message that school is canceled for the rest of the year, therefore I don't have to do anything. I think you really need to stay up with this. I'll have some information on Thursday about Central Washington, and I know that's important to a lot of us, but I think we want to stay on top of things here. All right? So keep on working at it. Please don't view this as an early summer vacation. It's only going to hurt you guys in the end. All right? Take care. Be safe.